solving logarithmic equations. So let's start right here. Now, if you notice before when we were solving exponential equations, what we did was we took the log on both sides to solve. So when we have this equation right here, we take ln on both sides. When we had this equation right here, we took log base 2 on both sides. When we have a log equation on the other hand, what we do is we convert to exponential form. Consider this. I have log of base x, a log of an unknown base of 25 evaluates to be 2. What I need to do is convert this to exponential form, which means drop the log and take the base to the other side. And so that tells us then that 25 is equals to x squared. And of course I take the square root of both sides. So I get that x is equals to plus or minus 5. But since x is a base, x cannot be negative. Because by definition, your base of a log cannot be negative. And so that means that x is equals to 5 only. Hopefully remember that the domain of logs are only positive numbers. And since the base are only positive numbers, except 1, we'll have a lot of restrictions on our answers because you can't plug anything into a log. Unlike if an exponential, just about anything goes in there. For a log, you have to be more careful with your answers. Let's try example number 2. Let's say I have a log base 2 of x plus 3 is equals to 4, and then I got to figure out what x is. Again, drop the log and take the base to the other side, convert to exponential form. And in doing so, I have then that x plus 3 is equals to 2 raised to the 4th power. 2 to the 4th power is 2 times 2 times 2 times 2, that is 16. And then one last step, subtract 3. X is therefore 13. Again, you have to consider the answer. Well, what to do right here? When I take this 13 and I plug it back in, I get a positive answer. 13 plus 3 is 16. And so that this is a good problem right here. The solution is fine. Like I was saying, you have to be aware of extraneous solutions. A lot more of your answers for these log equations just don't work out. Consider this example. Let's say I have log base 3 of x plus log base 3 of x plus 2 is equal to log base 3 of 15. I see a plus sign right here in a logarithm, and then my mind says, oh yeah, plus sign means multiplication. And so this simplifies to log base 3 of x times x plus 2 is equals to log base 3 of 15. Now that I have a log base 3 here, and I have a log base 3 here, and the two sides are equal, it means I don't need to consider the log anymore, and so I can simply cancel out those logs. So again, I break out my ninja stars, and I say, see, sayonara. And so I have x times x plus 2 is equals to 15, and of course this is a quadratic that I need to solve. By the way, no, x does not equal 15 and x plus 2 equals 15. This is simply incorrect. You have to use the zero product property, so you have to set the equation equal to 0 to get the answer. But this right here is a common mistake, so be careful. Distribute the x, that is x squared plus 2x equals 15. Take the 15 over, x squared plus 2x minus 15 equals 0. And this thing factors x plus 5, x minus 3, and so I get that x equals negative 5, and I get that x equals 3. Look at those two answers. Aren't they lovely? But then you remember, well, the domain for log, domain, M-E-I-N, are numbers that are greater than 0, right? So if I take this negative 5 and I plug it into the log, this is log base 3 of negative 5. Log base 3 of negative 5 is undefined. it means that this answer does not make sense. It means that that answer is simply wrong. Oh man. So I take the other 3, I take this 3 right here, I plug it into the first log, I plug it into the second log, and I plug it into this, well, the third one doesn't have an x, but if it did, I would have to. And I note that each of those are positive. And so therefore, I am not violating the domain of the log, and so that means the answer is x equals 3 only. This is the only number that satisfies the equation to this problem. Thus, -5, although we got it as an answer, is extraneous and thus not a solution to the problems that we have in life. I know. The last type of log equation, so again, you have this equation right here where you just have one log, convert to exponential form. When you have two or more logs, you first combine them together. So we combine these two together. What happens when we have something that's kind of in between? So, example, let's say I have log of x plus 2 plus log of x minus 1 is equals to 1 right here, and I'm trying to solve this equation. Well, the first thing I will do is I will combine the logarithms together. And so these two combine and give me log of x plus 2 multiplied by x minus 1. Of course, that's still equal to 1. And that is because of the plus sign right here. If it was a minus sign, then I would have to divide the logs. Now that I have this right here, I can convert to exponential form, which means drop the log and take the base over, correct? Well, but what's the base? What's the base? You have to remember, when the log has no base, the base is 10. So you drop the log and you take the base over, and so that gives us then that x plus 2 multiplied by x minus 1 is equals to 10 to the first power. Again, you cannot say x plus 2 equals 10. That's just wrong. You have to set it equal to 0 if you want to use the zero product property. So I FOIL x squared negative x plus 2x minus 2 equals 10. Subtract the 10 to get it equal to 0. I get x squared minus x minus 12 is equal to 0. And now I can factor this happiness and joy. So it factors into x plus 4. No, x minus 4. Oh, I made a mistake. This and this gives me a positive x. So here goes x plus 4 multiplied by x minus 3 equals 0. And so x equals negative 4, x equals 3. Again, can't just take those answers and I'm finished. I gotta take them and plug them back in. If I take negative 4 and I plug it in right here, what's negative 4 plus 2? That's negative 2. So that automatically means once it doesn't work one place, it's no good to us. So that means we don't need this answer. I gotta take the 3 and check the 2 places. 3 plus 2 is 5. 3 minus 1 is 2. That works. That works for us. And so therefore, this is the only answer. Again, you have to be careful, but that's all right. You know how to be careful now, right? Good. All right. The last kind of equation we have to look at is a special case of the first example, the very first example we did when we cannot make the bases the same of the exponential equation. So, let's say I have this equation right here. I have 2 raised to the x minus 3 is equals to 5 to the x right here. And unlike before, I got 2 x's up here. And so that makes my life a little bit more difficult, but just a little bit. The technique for solving this equation right here is to take a log on both sides. Technically, it doesn't matter what log you take, And so traditionally we take the shortest log, and so that's ln. So you take ln on both sides of the equation. And so it gives us 2x minus 3 equals ln of 5x. Then I use the power property of logarithms. The power property of logarithms says that this can come to the front as well as this. And so that leaves us with x minus 3 multiplied by ln 2 is equals to x times ln 5. The point being that I can now use algebra to isolate the value of x and solve my problem. The point being I can now use algebra to isolate the value of x and solve the problem. So I distribute the ln 2. So I have x ln 2 minus 3 ln 2 is equals to x ln 5. I gotta bring my x's together. So I will have x ln 2, the x minus 5 comes over here. It will change signs, so it will be negative x ln 5. The 3 minus ln 2 needs to go to the other side, so again it will change signs. And so this is going to be 3 ln 2. And now I factor out x. So I have x open parentheses ln 2 minus ln 5 is equals to 3 ln 2, and one step remains to finishing this problem off, and that is you divide by ln 2 minus ln 5. And so I have that x is equal to 3 ln 2 divided by ln 2 minus 5, minus ln 5. Now, this question in particular, this right here is the final answer. But if you're doing a multiple choice exam, this final answer can be expressed in at least 5 different ways. So unfortunately, I have to show you all 5 ways of expressing the answer. So watch carefully. Equals. I'm going to bring the 3 up, and so that's going to be ln 2 raised to the 3rd power over ln 2 minus ln 5. These two are equivalent to each other. They are the same answer, just written in a different way. Well, what's 2 to the 3rd power? 2 times 2 times 2 is 8. So I can rewrite this as ln 8 over ln 2 minus ln 5. Again, it's the same answer, just written in a different way. Now if I focus on the denominator, I notice I have a minus sign. Well, a minus sign means to be. And so I can also write this as ln 8 divided by ln 2 divided by 5. Oh my goodness, right? That's like 1, 2, 3, 4 different ways of writing this answer. But wait, there's more. I could use the change of base formula. I don't know if you remember that formula from, 5 years ago. But the change of base formula says that I end up with the same log on the numerator and the denominator. And so I can write this as log base 2/5 of 8. 1, 2, 3, 4, 5 different ways of giving the same answer to the same problem. Sheesh, right? But that's how you solve that problem right there. All right. Y'all have a lovely day.